I am audible. Alright, so we are in good shape now. Let's see, do we have this plugged in? Slides are on? Okay, perfect. So now I have the distinct pleasure of inviting a very esteemed guest on the AI and governance part. So you've heard of DPIs, DPGs in the morning, we heard about all the different facets of it, how complex it is to build. And now when you think of AI, nobody even knew what AI was a year and a half ago, 2 years ago, right? So everything has evolved in the last year. In that process, figuring out what actually has happened on the ground and actually having some use cases on the ground, that is what this group is going to do. So we have some very good experts who are going to take you through this journey of how did they actually take a DPG, take some problem and then solve for it on the ground using AI. And this is all population scale. So first off, I have the distinction of welcoming Professor Ramesh Loganathan. Professor Ramesh is a professor of code innovation at IIIT Hyderabad, one of the real premier institutes in the space of AI. Real techies are there. He's been leading a lot of research, R&D for the last 25 years, and earlier was a CIO for Telangana State Innovation Cell. And he also founded the Head Start Network Foundation and instrumental in establishing a lot of key initiatives at IIIT Hyderabad. So we're starting with Professor Ramesh. Why? Because Ramesh brings up two perspectives. One is at a top level perspective, what are problem statements out there? So nobody knows problem statements as better as Ramesh and how to solve them. But also he comes up from an academician perspective. So one of the things that we wanted to highlight is the role that academics play and academic institutions play in shaping such new things like AI. AI is not deterministic. You can't get 3 engineers and say, give me a sprint plan for the next 3 months. That's not how AI works. Nobody knows. Nobody can claim. If someone is claiming, they're taking you for a ride. So that is where academics come in. And that's the part that Ramesh so well plays. So let me invite Ramesh. What we're going to do is 5-minute lightning talks, and all the speakers, we also have, let me just take quick names and I'll keep introducing them as they come. So we also have Mihir Kulkarni, who's a machine learning scientist at Vadhwani, and welcome Mihir. And then we have Pragya Mathur, who's a senior consultant at Samagra, implemented a bunch of these AI projects. Welcome Pragya. And we have Praveen Chandras from Swechha. So Swechha is a non-profit that has done some phenomenal work. They've cracked what crowdsourcing means. They've cracked what reach means. So very eager to hear from Praveen as to what that magic is. So we're going to start with Ramesh and then go on from there. So 5 minutes, and all the speakers, there'll be a bell ting tong for after 5 minutes, and after 6 minutes, the bell is going to go crazy. So please don't attempt to go beyond that. Okay? Over to you, Ramesh.
Okay, just to get started. So I'm going to talk about, like Rahul said, the many things we try in writing. Translation is a big part of what we do. Research anyway is there. We are one of the largest research groups in the country, 50 faculty, 500 researchers, and research output has among the top 1 or 2 in the country. All that is there, but we also have extreme focus on creating solutions from research. Research translation is a big part of it's an aspirational focus, not easy. Research is hard, but translating research is even harder. And so we have many structures, and one of the structures that we have created is 4 years old now. The Smart City Living Lab, set up by the Smart Cities Mission, and Smart Cities Mission, and what's the older? Okay, fine, I will talk to it. At Trinity later. But I'll just pick the right slides. So it's set up by the National Smart Cities Mission and Ministry of IT Government of India. The whole campus is a live lab, and to create solutions from innovation and solutions from research and startups. Right? And the big part of any real world, especially in the research, academic research environment, we are very removed. Academics is very removed from the real world, right? Both physically as well as metaphorically. And so the understanding of real world problems is very limited. So these two worlds are not just not necessarily, they're quite far apart. What research does and what the real world needs. And so one big part of the living lab model, so this is a living lab setup, and it's not just that the campus is a live lab, which it is, but the living lab is more than that. Living lab is actually a live knowledge lab, right? And the idea is that If you don't get the right stakeholders in, whether it is the government, in the case of smart cities, the adopters, right, the likes of CBRE and such, or the property developers, the researchers, the corporates that are supplying technology to in the smart city space, and of course the startups. If you don't get all of them in and have regular conversations, the discovery is going to be, like I said, they remain very, very non-intersecting. And to make them interested, you need to bring them in and then make them talk. It's not like a company will come and tell research will build this for us, or like you tell a startup will build this for us. It's a discovery process. Research is doing this, startup is doing this, there is this problem, there is this policy happening. And then you change things, add something to the problem, you take two research works, come back to the startup, right? And there's a discovery of problems, possibilities, and actual solutions. So that's the dream plan. Now, to make it happen, you can't just have the conversations. You also need to have a physical setup where it happens, right? So the campus is the physical setup. And again, in the smart city case, data is a big challenge. I mean, we all see those IoT sensors, small sensors, whether it is garbage tracking or like things like that. But those are very tactical. In the real world, you don't have one sensor. The city will have hundreds and thousands of sensors, right? And you take things like garbage, then it's really tens of thousands. So this is dealing data at scale in a very, very heterogeneous environment. You take something as simple as cameras on the streets or like any kind of garbage monitoring. You'll have multiple vendors, so it has to be standards driven, both in terms of how the information is captured, how it is organized, how it is communicated. At the same time, we solve for multiple vendors. So you can get standards and the models are very, very, very important. So the whole campus is a live lab. We have adopted one with B standards, an open source standard that Europe was pushing and India was part of the whole standards body, but in the last couple of years, government has adopted it as one of the standards now, primary standard for smart cities. And so that's we have adopted that as the representation standard. You get the information model for multiple verticals. And so you have and then you have the sensors, so you get the data. And so we have about 400 sensors on campus in the 6 or 7 normal verticals like water, energy, solar, and such. And so it's a live setup in a standards-based platform with an infra and such, and we were doing it. Now recently, Smart City Mission has come and said, like RISE is working on IUTX. If you know IUTX, that's the interchange standard that RISE has been working on, which is between different entities. We are working on the sensor level, sensor network and the standards there. And so Smart City Mission now wants to put this as an integrated stack and take it to the smaller cities. The first 100 cities is over. I mean, they won't publicly declare failure, but it's a visible failure. But now they're going after the next 250 and then eventually the next 6,000 cities. So there they need a different approach. So this is going to be hosted in a state data center. Any number of cities can come on it. They just need to get the sensors, follow the standards, and once they push the data in, the solutions are available in the dashboard and the analytics that are built. So that's possible because of standards and on the one hand, we are probably one of the largest implementations, very few implementations in the country, and one of the larger ones. And the idea of the lab is like you have the data, you have the various stakeholders coming in, whether it could be a startup or somebody building a solution coming in to test something and they need live data. It could be like solar power generation or power consumption or water consumption or water quality. They need live data to test out something that they built. Maybe an algorithm, maybe an optimization, maybe just monitoring. And so they can come and test it. So it's a proving ground, so they can then go to cities and say, like, we've tested it in the living lab. And so getting all of them in is the key. The framework exists. There's a live setup, production grade sensors, and of course we can't buy expensive sensors. It's as an academic institution, we don't have that kind of money. And so where we couldn't find an inexpensive sensor in the market, we put it together. In some we just buy the sensor, put the whole electronics. Some we buy an analog meter, make it digital, or get a digital meter and make it add a communication layer to it. And so it's a live environment with, like I said, all those sensors. The layers is very important. The top layer in this is IUTX, right? But the layers underneath, there is a sensory layer, there is sensors, there is a communication layer, there is information representation layer, it comes to the data lake. There you can either take the live stream, you can subscribe live stream, or you can subscribe to the archive streams if you want to build models and such. And so these are a lot of the work. It was 2.5 years to just kind of get a good handle around this and the whole thing built and working, where now we have about 8-9 months of data that is archived for all the 400 sensors. If somebody wants to build some models, they could get the data and it's built it. And so the data that is there for a live campus for building or verifying models is now built in. Like I said, about the last 9 months we have, and it's continuing to build. So the information model is key. One and two is a representation structure on how you package information, how you push it, right? And but then you also need to have, okay, what are the water fields, what are the energy fields, what are the solar fields. So we've created a kind of a model which now Smart City Mission is just giving it as an indicative model because they can't mandate. They want to eventually create standards for even the information model. Right now they're giving it as the information indicative models. So I will just leave it on this last slide. So the knowledge sessions are key. So we do a lot of roundtables. We have conversations where we get different stakeholders coming, close to meetings, 15, 20 people, 3 hours we generate white papers. So most of these in the last 2 years, these are about 8 different roundtables. They're all on the website. If you look at Smart City, Smart City Lab, you will find the portal. So we do that. So that's a very, very quick introduction to the Smart City Living Lab as a model. I will leave it on this slide. Okay. Thank you.
Okay, thank you so much. That's wonderful, very insightful. So, we talk about builders and contributors, but unless you have playgrounds to test it out, contributors also don't feel some sense of fulfillment and builders don't feel that, and that is what this is. So, wonderful concept. I wish more folks like this created this. So, all this thing is up there, online, open for people's consumption. Of course, DPG Dialogues contributes to Bhashni and all. I know Ramesh can go on for an hour. But thanks for sharing that, Ramesh. This is very useful. Next up, we've gone macro, right? How do you set up playgrounds? Now let's go micro into AI, right? When you think of a small model, how do you train a model? What goes into actually building out a model? And so next up, I'm going to invite Mihir Kulkarni. He's a machine learning scientist at Vadhani AI. And Vadhani AI specializes in a lot of AI projects across different domains, across different states. And the one that Mihir's built out is the TB and maternal health areas, models for that. And so he's built out in TB adherence models, COVID-19 forecasting during that time, helped Mumbai's BMC and so on. And before that is always into data. So please give me a big round of applause welcoming Mihir.
Hey everyone, hi. I'll be speaking about our work in the tuberculosis cascade today. So I work at a place called Vadhani AI that aims to build AI-based solutions for the most underserved people in our country. We know that AI as a technology really serves today privileged people, especially in the Western world, and we're trying to get it to India. And our institute aims to deploy it within the public sector so that we can benefit people who need it the most. So, in terms of operating model, what we do is we partner with governments to start with. So, we sign MOUs, get access to privileged datasets, build solutions, co-creating them with the government so we can have our solutions sit within existing government infrastructures. We then also help them to sort of train their own staff to be able to use these solutions and eventually deploy them in the field at scale with the plan to finally transfer technology once our development is done. Now, moving on to the problem of tuberculosis. Tuberculosis is a massive problem in our country. We have like 10 lakh or so cases overall, and around 3 lakhs in the country. The number of patients has been kind of stable for a while, and it's a big priority of the government to try and help reduce the prevalence of this scourge. We have a lot of data in TB. There's a so-called Nikshay portal that has very rich information on every TB patient in the country, which is why we identify TB as both an important public problem, but also a domain where data and sort of infrastructures could deploy AI solutions exist. So we are the official partner of the Indian Central TB Division, whose mandate is to sort of look at TB. I'm going to talk about the TB cascade, which is essentially different stages of your public health problem. So you start with sort of identifying the cases, identifying where TB patients could be, and trying to go and catch them where they are. Then you actually have the problem of diagnosing them. Do they have TB? If they have TB, do they have blood-tested TB? All of this needs kind of testing and screening and diagnosing more efficiently can lead to big gains. And then finally, when they're in the system, can you actually manage them better? Can you predict which patients are likely to have adverse outcomes, which patients are likely to have good outcomes, so you can triage and essentially do efficient resource management. So there are multiple such problems, and we have a suite of 4 solutions in this space. One is for using AI for vulnerability mapping that helps identify which areas could be hotspots. Then we have a screening tool, which is a cough-based solution where you essentially cough into your phone and the model tells you whether you're at risk of TB or not. We then have the line probe assay that automates some of this drug sensitivity testing, which is a very important thing in the TB space. If you're drug resistant, you have a much longer course, you have a bunch of new medicines, and identifying drug resistant cases is important. And finally, we have the solution where we try and predict which patients are likely to have adverse outcomes. So I'm going to spend some time talking about the final solution I just mentioned. TB has a long sort of treatment regimen, and a lot of people, especially people without education, will not finish their treatment before they're supposed to. And this can lead to both drug resistance, but can also become super spreader in the community, leading to death of themselves or other people. So adherence is a big deal in public health, especially in TB, and it's of importance to identify sort of non-adherent patients before they actually have the adverse outcome. And so we like to essentially do triage. Like at the point of treatment initiation, we like to identify which patients are likely to actually have the adverse outcomes before they go adverse. So health workers who are limited number can target the right patients on time. So here's how our solution works. We take in information from Mixture, which is the patient portal of the country. We also have adherence data that refers to the behavior in the past. This is then fed into an AI model which predicts which patients are at high risk and which patients are at low risk. This is information that's sent into the health worker's phone, and they're given a list of people to call, and that's essentially the solution. It sounds simple, but there are some very interesting technical challenges which I hope to sort of summarize in the next slide. But essentially, in summary, we've had good results on the modeling, and there's been a lot of uptake on the field. We're currently in 12 states, and we're getting pulled from more and more states to deploy. We're hoping to be pan-India by the middle of next year. So here's like a simple description of the machine learning pipeline. You start with patient data from Mixture, which is line-based data. You do what is called data cleaning and processing, where you try and understand which data to use, which data not to use, whether a certain geography is good for deployment or not. You then do something called encoding, where a lot of the variables are categorical, but machines can't read sort of words, so you have to convert them into numbers, and there's a lot of experimentation we do to identify the best encoding to represent the data well. We then feed this into the machine learning model. For those of you who are technical, it turns out that for most so-called tabulated data tasks, it's not really deep learning, but it's this classic model called the boosted tree that works really well. So whenever you have a spreadsheet, something like a boosted tree is the model to use. And then we ensure that we're able to do the prediction at a district level. So for each district, you have a different threshold to use, because certain districts may have a different risk profile, they may have a different amount of bandwidth to allocate their resources, and so we pick the threshold based on the district. Slides. Okay. So we actually submitted this technical work to a conference called the Machine Learning for Health, where we got the best paper award. So if you just scan and like look at it in your free time. But essentially, we analyzed a few aspects which I think are very interesting for people in the public domain. I think the first thing to realize is that machine learning model has to be compared with what's on the ground. Now, typically in a lot of sort of triage cases in India, there isn't like a very good protocol or baseline. There's something and people kind of follow it or not based on where they are, or like based on how the health program is there. So the first step is to actually codify whether like an on-ground protocol that's not ML. And if you see the top sort of left graph, it shows that the model, which is the curve on the top, comprehensively beats the baseline, which is like the pink line, which is a representation of what happens on the ground. Then you also have this question of interpretability. When you deploy a model on the field, people want to know why a certain patient is high risk and why a patient is low risk. So it's important to tell them which features are important, which are less important. That also help them inform their interventions. And so interpretability is an important thing. We also have aspects of fairness and robustness, which you can look at the paper. But all of these are very important as compared to just building a model that you can deploy. A lot of people get into sort of machine learning wanting to build like the fanciest models. But what we found is that what's around the model is much more important than the actual model itself. So let's talk about it. Thank you.
Thank you so much. It was good to get a glimpse, micro, right? To actually see what goes into it, and 12 states and running. Amazing work, man. Amazing. Thank you. So next we have Pragya Mathur, senior consultant at Samagra. For 5 years she's been with Samagra, successfully managing programs across education, agriculture, health, nutrition, benefit delivery, even tribal development across Odisha, Uttar Pradesh and Haryana. Currently, she leads the Kushal education, focusing on school education readiness, and also she's been involved in a lot of figuring out what does AI strategy mean for at a state level. And so, what we're going to do is now we went micro. Let's get back macro again. let's see some of the things that Samagra that we've built in terms of population scale AI deployments, leveraging models from Bharshni, leveraging things, building out a framework, a platform together to actually deploy these things quickly. So over to you, Pragya.
Great, good afternoon everyone. So like Rahul mentioned, today I'll speak about some of the learnings from our work in AI. But let me straight away deep dive into how do we look at AI in governance, right? There are three ways to do that. One is AI for internal productivity. Similar to what Mr. Saurabh Gaur was mentioning in panel 1 today, AI boot camp for government officers, right? How can AI be used for better efficiency among government employees within the government? Summarizing meetings, minutes of the meeting, right? Summarizing a big fat government file. How can we use AI to do that? The second is AI for impact, citizen-facing use cases, right? This could be direct kind of AI use case for the citizens, or it could be through a frontline worker like an ASHA worker, Anganwadi worker, teacher, and so on. The third here is AI for economic growth. How can state governments really look at AI as an industry and use that as a lever for economic growth for their particular state? We'll not spend too much time on the first one, we'll spend time on the second and the third. Going into the second one, Samagra in the last 18 to 20 months has been on this journey. We're calling it the gov.ai mission, which is really driving at-scale uses of AI in governance in India, right? And I'll talk about some of the things that we've done here. The first is what we call Krishi Sahayak, right? This is a chatbot for farmer advisory, right? Think a farmer being able to ask any questions about prices, pests, weather, government schemes and so on. Right? So an instance of this is live right now in Odisha. It's called Amakrushi AI, and we have another one in UP. It's called Krishi Mitra AI. And this is sort of very successfully going on, and in their vernacular, natural language, farmers are really able to ask any question that they have. The next we have here is Jan Sahayak, right? Here, think that a citizen is able to ask any query that they have around any government scheme. An instance of this is live pan-India right now, where farmers can ask questions in 11 different languages on the PM Kisan scheme, right? When is my next tranche going to come? Am I eligible for the scheme? So on and so forth. And we've received more than 80 lakh queries on this one. The next is Nipun Sahayak, right? This is live right now in UP by the name of Nipun Laksh app. Really, this is a thermometer for foundational literacy and numeracy, where a teacher can administer a 3 to 5 minute test and get to know whether a student is Nipun or foundational literacy and numeracy competent or not. And here we're seeing more than 50 lakh assessments month on month. And the last one here is Kumbh Sahayak, right? So we all know that the Mahakumbh is going to happen next year in 2025 between Jan to March. This is going to be a co-pilot for any visitor visiting the Kumbh, and we expect more than 24 crore people visiting the Mahakumbh this year. So here any visitor can really ask any query around the Kumbh in multiple different languages on this chatbot. I'm actually going to skip the video given the paucity of time. But really I want to focus on what have been the learnings in this entire journey for us, right? And at Samagra we always say that only half the job is done when you launch something. But with the experience of last 18 months on AI, we know only 20% is really done. And you have to really then work a lot more to get it right, to really get the accuracy right and make it useful for the users. And initially we had a positive rating on these different use cases that we have to the order of 20%, and we've now taken it up to a 85-90% kind of positive rating by the users. And there have been several learnings, some of which I'm going to talk about. The first one here is domain-specific dictionaries, right? So every geography and domain combination has its own kind of terminologies, which any sort of LLM will not naturally understand. So you have to really work with experts to develop these dictionaries so that the understanding of any query being asked by a user is really understood. The next one here is understanding the intent of the user. So our users are not asking very articulate, well-crafted questions, right? you really need to figure out a way of cross-questioning with the user to really understand what they're asking and give them a accurate, relevant answer that is useful to them. The next here is state expert content, right? So LLM, if it just looks up information available on the web in the open source, then can give you a generic kind of an answer, right? So you really need to build expert content using the government, state government's expert repository, put that at the center of this, and really figure out how to structure that unstructured data to answer questions. The next one here is traceability, right? So any answer that's coming to a user, you can't say that an LLM has hallucinated and hence this is the response that's coming. You need to have an audit trail as to where this response is really coming from. And the last one here is concurrency, right? So when such at-scale usage is really happening, you really need to figure out how to optimize the compute and the GPU usage that is happening. So these have been some of the learnings, and just a quick 30 seconds on, So we also, all of what you heard about is the core tech of that is something that we're calling the Bharat Sahayam platform. And really this can become something that can power any such conversational use case in any domain. On the last one quickly, so as we know, NITI has come up with the India AI mission, the vision of it, which has already been put out. They're really now figuring out how to land that. What's been interesting is that all state governments are also really asking the question, how do we land this in our states? Right? And they want to really use it as a lever for economic growth. A very quick example of that is, can data annotation come up as an industry, right, in the state and provide a lot of jobs to people? So that's just a quick example of how that can be done. The state of Telangana is really taking a lead on this. They've recently in the Global AI Summit early September, they've launched their own AI roadmap, and Samagra also had their own contribution in building this, and there are multiple other states across India right now who are on a similar journey of figuring out their own AI roadmap.
So while I'm talking on behalf of Swecha, the project that we are doing, Mission Indian LLMs, is a combined effort, and I'll take you through this very quickly. Let me turn on my timer as well. Alright, so Mission Indian LLMs, and the first subset of that is what we are calling the Sata Sahasra Yagam. Sata Sahasra, 100,000. Yagam, you know, right? Let me talk about what is it in a bit, but who are we? Right, who are the, let's say, the stakeholders of this? The stakeholders of this is open source enthusiasts, researchers. Impact is a big part of it. IITs, IIT Hyderabad, IIT Madras are a big part of this. We are associated with the industry. Ozone Tel Meta is also supporting this initiative. There's policymakers, there's researchers, there's academicians, everybody who is involved with this. With a common theme, we are all working towards AI for society. Can we make AI work for the society? That is the common theme in which we are all working together. And what are we building? To begin with, we are going to build the Telugu LLM. We are also going to capture the cultural aspects, which I'll come to in just a bit. We want to increase the knowledge available in AI, the talent pool that's available in AI, and so that, let's say, in 3 years, can India become the global hub of AI? Right? This is the common vision statement, mission statement for the group of people who are working in this. What have we done earlier? If you can see over here, the first thing that I would like you all to see is the Swecha Guntuka project. It's a Telugu ASR model that runs locally on your mobiles, less than 200 MB, no internet connection, nothing required. And it had around 45,000 people contributing, or 50,000 people contributing from across the Telugu-speaking states of Telangana and Andhra Pradesh. No money spent. We are not like the whispers of the world. No money spent. These were all people voluntarily contributing their data. This is what we call a people-sourced LLM or people-sourced AI model. People-sourced model is what we are calling it. Right? And we had about 1.5 million voice samples from every place in these two states, so that whatever dialect you choose, whatever accent you choose, we should be able to get it. And right now, we are proud to say that we are one of the best ASR models. Telugu obviously is the best. We are getting more than 95% accuracy. That proves that there is a model that can be applied for AI as well, the people source models. We had done previously, before that, as a POC, we had done what is called the AI Chandamama Kadalu. Chandamama was a very popular magazine back in the day, which used to publish these small moral stories for kids and all. And we took inspiration from the Project Gutenberg. Some of you of my vintage will know the Project Gutenberg. where you do OCR, but you also do the proofreading sort of thing. 10,000 contributors, one single day, they had proofread all the pages so that you could use that to create a Gen AI model, which would tell a small story, 4, 5 line story in Telugu. So this was done last year. Gurtka, we had released it this year again. The datasets are open source. The model is open source. In fact, we are working on different licenses for the datasets as well, because we understand now that the CC licenses that we have today for datasets are not really sufficient for the datasets that we are going to release tomorrow. The CC licenses we have for data content today are not really sufficient. Some of the other work, I'm going to skip for now. I'm also going to skip the vision, but let me come to the problem. The problem that we all see today, or at least we see today, is that the current AI technologies are all geared towards the global north, because primarily they have been built by the global north. The knowledge that they get from the data that they get from the information that they get from is all from the global north languages or the erstwhile colonial languages. Now you see all the Indian languages, let's say the Latin American languages or African languages are called resource poor languages. We are not resource poor, we are not culturally resource poor. When people say resource poor, they say they are resource poor because there is not enough digital content. And in what languages is the digital content present? Only perhaps English, French, Spanish, maybe Portuguese, but these are the old colonial languages. And by virtue of being colonial languages is the only reason why they have a lot of data available on the internet, right? So that is a problem, and what does that happen? It also means that the culture of the global north is overrepresented in the LLMs, while the culture of the global south, Indian language, let's make it very more specific over here, right? Let's say Telugu. The culture of Telugu is not represented in LLMs. You will have some data because there is obviously some, and you know that the biggest LLMs in the world have evaded copyright and taken information from the newspapers and everything. However, you will still see a problem. Right? You will see the problem that the global south knowledge, culture, languages, everything is underrepresented in the way the current LLMs are set up. Right? What do? We are trying to come up with solutions saying for global south. How are we trying to do that? We want to democratize AI. When I say democratize AI, we want to democratize the building of AI and access to AI. There are two key dimensions. One is the building and the access. First way to do it is what are we calling the Sata Sahasra Yagam. Can we involve 100,000 engineering students in the state of Telangana and Andhra Pradesh, 100,000 engineering students where we train them on AI, where we also contribute by just speaking about their culture. Right? I'll just come to that in a bit. I talk about where we are. In fact, I'm talking, 30,000 people have already completed this internship, and we have collected around 45-50 million tokens a year. But we have a massive ambition. We want to reach 1 billion tokens. Our hypothesis is that for Indian languages, you do not require 1 trillion tokens to come up with an LLM. We are working on our own tokenizers. Tokenizers for English cannot be applied directly to our Indic languages. So that's something that we are working on as well. Right? We can. This is the steps, we have a detailed plan as to how can we reach 1 lakh people in terms of collecting the data and how do we engage 100,000 students. But I'll leave it with this slide. We are making data collection as simple as possible. This is a very simple mobile app where you can select the category that you want to speak about. Now we have an ASR model. Otherwise, how do you capture the data? How do you get digital data? Typing is impossible. Telugu Wikipedia is minuscule compared to the English Wikipedia. You don't have Telugu data. How do you do it? I will go and talk to 1 lakh people, ask them to record 6 minutes each. I get 10,000 hours. What do they talk about? Cultural aspects. There is no validation of a cultural aspect. I'll ask them to talk about a story their grandparents would have told them. Ask them to talk about recipes. Ask them to talk about traditions, culture, attires, local festivals. All of these things is culture. All of these things is local knowledge. Once we have all of these things in a data set, then building an LLM for you folks is a trivial task. And that is something that we'll do it by the end of the year. Thank you so much.
Absolutely phenomenal to hear all the work that Svecha does, and this people-sourced AI, right? There's open source and people-sourced. That's the best combination. And for AI, I think there is no other choice. It has to be people-sourced. Otherwise, how do you get that data? I have also experimented myself, but also seen a lot of folks struggle in AI when you do it paid source. So you hire someone to collect data. And wherever you're paying someone money to do something, they will always take shortcuts to getting you that data. So that doesn't work well. You don't get good quality data. So something that is actually donated always gets you high quality data. So what are we going to do now is assemble these four illustrious speakers into a panel, and we have about 10 to 15 minutes. We're going to grill them with questions, okay? So taking cue from Praveen's presentation, we're going to start with crowdsourcing questions. And then I'm going to just pick and choose some of these questions, some add more, but we'll cover as much as we can. So what we'll do is pass a mic around, and hopefully you can just call out your question. I'll note them down. Keep going with your questions, rapid fire, please. No long questions, just a specific question, not too much long context. Question in 2 lines, and we'll pass it on to the next question. And let me please invite Professor Ramesh, Mihir, Pragya, and Praveen on stage, please. Please. Absolutely phenomenal session. Very, very nice. All right, anyone want? Questions?
Hey, in the morning session, hi, I'm Ashish. In the morning session, you were told that one of the areas to focus would be learning outcomes. And with the advent of most of the work that you're doing, how would you articulate the outcomes? It can't just be number of sessions done, and that's very old school, right? And just the data of how many people we train, it's not an outcome. How do they really use it, right? What has changed in their life? So what are you doing in each of your areas of work? Because this is mass and scale. So how are these outcomes being articulated in your area?
No, thank you. Great question, and we'll toss that to Pragya to talk about how ORF actually gets measured. More questions? I'll just take questions so I can squeeze it in that 15 minutes, okay?
Hey, this is a question for Praveen. You mentioned something about your hypothesis that we might not need as many tokens for Indian language. And intuitively it does make sense, right? Because there's so much English data, it makes sense that what the solution that they came up with relies on this data. I'm just curious if you could expand more on that, like what would small language models look like, and how should independent developers look at this problem?
Okay, great. You have a question from an independent developer perspective for Praveen. Okay, more questions? Okay, JK there and gentleman in front here.
Hi, this question is for Praveen sir. You said about that if you have sufficient data, you can represent culture. So I have a doubt, like how would you represent such random data into what fields? Like I also have a lot of doubts about how tradition can be reinstated in people's memories, like they have been deteriorated over time. So how will this be represented?
Okay, great. JK behind.
I think we were talking of people sourcing, and I also have an at-scale problem. I'm part of NPTEL IIT Madras as well as the data science program at IIT Madras. Both are at-scale learning programs that we are
So if anyone has taken a Swayam course, everyone heard of Swayam? JK is the brains behind it.
Sorry, you shouldn't say that. So yeah, it's not the brains, but currently I'm helping out in
Runs all of the tech. So at scale, lakhs of students taking those courses is all.
Yeah. So I think I have a question to all of you. As in, see, learning. So the data sourcing is one part of it, but there is also a need for getting students to actually do the LLM kind of thing, more at a project kind of thing. So in each of your projects, are there scope for at-scale models where, so what I'm saying is we have a pool of students who are taking very specific courses and other things, are there options for open projects, maybe voluntary projects also, which can be opened up for students in either NPTEL or the IIT Madras programs, which is open to all? That's
awesome. No, thank you for the questions. So we'll start with those four, and if we have time, then we'll go for more. Okay, so let's start with, I think, excellent questions. Thank you. Very precise, very powerful questions. So let's start with, the first question I think Ashish asked, which was learning outcomes. So Pratya, I'll direct it to you since you have been so involved in that. The question was, you mentioned learning outcomes in a loose way. What does learning outcome really mean? What are you really measuring? What is the precise point there? Can you give us a flavor?
Yes, great question. Thank you. So in the Nippon Bharat mission, in fact, the Ministry of Education has defined exactly what competencies of literacy as well as numeracy for grades 1, 2 and 3 are students supposed to attain to be called Nippon, right? To be called FLN competent. So that solves some of the problem there, that it's been made that specific and simple. One of those competencies is ORF, oral reading fluency, X number of correct words per minute that a student can read. Right? That specifically is one of the competencies that is very hard for a teacher to measure and keep measuring in a standardized way for all of the students in her classroom, let's say month on month, right, to see their progress. Because you're almost on a watch trying to measure the number of correct words per minute a child has spoken, right? So a tool that can really measure that in a standardized way is game changing. Right? So that's one part of the problem. Now if you, at a macro level from a state government point of view, look at the mission itself, that you're motivating 4.5 lakh teachers across 1.1 lakh primary schools in the state to embark on this mission, where if let's say you have 50 students in your school in grades 1 to 3, your target is to make all of them Nippon, right? Now the only way to do that is that in the run-up to a credible third-party assessment where the state can really credibly measure how many students have become Nippon, in the run-up to that assessment, teachers are really preparing their students for that, right? At their own level, my job is to make my 50 kids Nippon, right? I'll only be able to do that if I have an easy, quick thermometer tool to be able to keep assessing. Every month, I track the progress of every child of mine to be able to do that. That's the problem that Nippon Lakshya app is solving, and that has really brought about outcome orientation in the system, right? So now you know what the outcome is, what the competencies are, and you're able to track that month on month for every kid and see if you're really reaching there or not, right? And that's not, the learning outcomes there is not something that we're tracking in the sense of how many kids have become Nippon in these teacher assessments. We're looking at usage. As long as teachers are doing that, that means that they're preparing for that third party assessment and really working towards that target. Now, at an outcome level like you asked, that is being measured by a third party assessment that's happening in the state. There are two types. One is happening at a school level. Every school can kind of get assessed by this third party entity called diet trainees, students who are learning to become teachers right now. They are used as semi-impartial kind of assessors because at this kind of a scale only they can do this kind of an assessment. There will also be a sample-based kind of third-party evaluation assessment agency that will come in and do these assessments. Right now in UP, 16,000 schools as of December 2023 when the last third-party assessment happened, 16,000 out of 1.1 lakh schools came out to be Nippon. Right? And we strongly believe, and of course there are 10 different interventions coming together to make this happen, but we really do believe that this has happened on the back of NL app bringing about outcome orientation across these 4.5 lakh teachers, huge system.
And then you slap on RCT on top of it, or get a JPAL kind of method. So there's a lot of good methodology that JPAL has come up with on how to actually quantify this evidence. Hopefully that gives you a decent idea of outcomes. Great. So then let's move on to small models, and I'll direct this to Praveen and Mihir. Would love both of your thoughts. So as an independent developer, right, of course small models are fascinating. Why are small models fascinating? Is because you can run it on your laptop. So many of you developers may have tried Olama, tried small 5.3, Llama 3.2, Llama 1 billion model is pretty cool. So something that runs on your laptop without spending money. So that is why small models are of course very affordable, they can scale, and so that's everyone wants to do that. Some of the things that Praveen mentioned, like a tiny stories equivalent for Telugu and all, are very nice developer things to start with. Could both of you tell us, from let's say a whole bunch of developers sitting here, how should we start thinking about it? If you have to think about starting with small models, should we start with a tiny stories? Should we try our own LLM? Should we try a GPT-2? How should we think about small models and how much data do we really need to make it work? Would love both your thoughts on it.
I'll take this first. And I'll speak from experience. Right? When we built this Chandamama Makadru, in fact, Tiny Stories was the inspiration. And we thought we would do this in Telugu. Primarily, Tiny Stories also because the amount of data that's required is quite small. And we have a source of Telugu stories. You don't require 1 billion tokens to do this. We probably had a few million tokens to begin with. Right? This was even without our own tokenizer. We used a readily available open source English tokenizer. And I tell you the advantage with using your own tokenizer for Indic languages. What we found out when we are doing this corpus collection for the Telugu LLM is that if you roughly say get about 1 million unique words, the number of tokens that are being generated is probably 10 times more, 6-7 times more than that, right? The number of unique words versus the tokens. So I'm saying the number of unique words, the number of, not tokens, the number of unique words or the number of sentences that you need to get to a good, reasonable number of tokens for Indic languages is far lesser as compared to what we are seeing with English, the trillions of tokens that you require. So to begin with, Tiny Stories sort of a thing where you have a few, let's say, a few million to play with, you get a good Gen AI. Let's say, it's a small, 4-5 line story sort of a thing. Might not make much sense from the culture aspect as well, right? But that's what you're trying to imbibe. Again, I don't believe LLMs have consciousness or they have any language. They're just essentially statistical machines, right? They're just next word predictors in some sense, at a very, very, very abstract level. Where this culture coming in is, if a kid today asks a ChatGPT to tell a story will be told without any of our nativities, without taking into any consideration of our culture or other things, right? Now, the only way to redress that is to actually bring in more data about some of these things. This is to answer the culture question as well. But I think Ramesh can talk more about the projects that we're doing for the internships and other things to answer your question. But just summing it up, right? Just 3 examples. One is Chandamama Makadru was a few million tokens. We were able to do pretty decent work in Telugu. We are reasonably sure this can be replicated in other languages. ASR model with around 2,000-3,000 hours of data is what I believe, right? 3,000, maybe 4,000 hours of data. 4,000 hours of data is exceptional quality. The good part is phoneme based. Right? This is all phoneme based. I don't really need to know the language. So which means from Telugu to Malayalam to Tamil or Kannada is a fairly straightforward thing. Hindi has the schwa syncope, giving the schwa. So that is a small correction that we need to make. But otherwise, 4,000 hours of data when Whisper had tens of thousands of hours of data for English. That's another thing that we found. And the last part is where, let's say 1 million unique words is giving you at least 6 to 7 million tokens. I thought SLMs also for a particular topic, like we were also thinking of the mixture of experts model. Right? Take a particular topic, train your data, fine tune on it. One last part is we have tried different things, as you said, right? We have tried BERT, we have tried GPT, we have tried everything.
What's a good one to start?
For each of these things, we have tried different things. For Chandamama Makadru, BERT actually came out better. We have tried Mistral, now Gemma has come up, we haven't trained on Gemma yet. But for the LLM thing, we were thinking that we could perhaps take up Llama, right? Given Llama has already trained on other things, and compared to BERT and Llama, we believe Llama is slightly better right now. We are looking to fine tune Llama. However, our thing is to build a foundational model from scratch, tokenize just everything, and then do this. Once we do this, all of this will be only open source. That's what Swechha does, and that will be out for the community.
Super. Main comments on how do you get started with small models?
Sure. I must preface this by saying that this is not my area of expertise. I don't work regularly on real languages. That being said, having been in the space for like several years now, I think one thing we notice in a lot of sort of Indian context, or especially like the low resource context, is that there is a significant lack of data for evaluation. So when I talk to professor, I talk to colleagues, one thing that keeps coming out is there needs to be more investment in collecting data and understanding how do you evaluate sort of these cultural aspects or other aspects that may be more specific to local languages compared to English. It is true that you probably need less data for local language compared to English because you can fine tune from like a large language model, distill into a smaller model using some techniques. But in the lack of good evaluations, it's going to be really difficult to understand if it will be well or not. And so the research community increasingly, for example, Dr. Kavali at Microsoft, among others, are trying to sort of create data sets and create evaluations to help understand how to even sort of measure performance in these languages. And once you have that, I think it will be possible for a research community to develop better tools that actually do the task you're interested in.
No, benchmarking is a very important, lesser spoken about challenge. So thanks for bringing that up. Then the last question from JK, which was around how do you get students to help do this? And I'll direct that to Ramesh. So think of framing that problem a little more flavor to it, more masala to it. You have tons of Swayam courses. You have a Bachelor of Data Science in Machine Learning and so on that IIT Madras offers, and about 3,000-4,000 students every year enroll for it. In fact, many people nowadays, you have resumes, they'll have bachelor's, BTech in something from some college, and then they'll have BS in data science from IIT Madras, and it is a proper degree. So now, there are these opportunities of courses. There are projects in these courses. So Bachelor of Data Science has projects in there. How do you create get all of this stuff done? Small model creation, crowdsourcing, all of this baked into the projects that are already being given part of Swayam, NPTEL, and bunch of other initiatives like that.
Very, very hard problems. Like, C4GT, when you do these summer camps, 50,000 students, how many students participate?
20,000
students.
Come in the community and then about 100 participate.
And given the nature, the fellowship and everything, it attracts probably the best in the country. If you're getting 20,000, I would say there are 20,000 out of the total 20,000 that are interested in the country. Right? So, and we have just, if you just take in and around Hyderabad, there are 1,000 students per batch. So if we target second and third years or third and final years, there are 300,000 students just in and around Hyderabad. You take both the Telugu states, which is what we generally have access to from Hyderabad, probably around 300,000, 400,000. Now, extremely hard. There are two examples in scale just to get indication.
What makes it hard?
So one college, the tier 2 college we're working with, which is about an hour and a half from Packnett, probably tier 3. It's not even in a town. Okay. It's on a highway between two towns, and like mostly people that come, more than half the students from villages within 20-kilometer radius. And so it's a 3-year intervention to get 20 students to build something in the final semester.
Oh wow.
Slow intervention, because like we every
Is it a motivation thing or a competence
yes,
thing?
Our system creates completely uninterested students. Right? I always say you find one medical college student who's doing it because like I don't know what else to do. They want to do medicine because they know it's very, very hard. And we can't say the same about engineering students. Right? Like 95, 98 out of 100 are doing it because they just don't know what else to do in life. Right? And zero passion. Which is the contrast, right? I mean, made almost everybody, because they're going very hard, it's very hard they've come. So we deal with that, and the system has created that, also the coaching culture. So we inherit in the colleges people that have just lost their zeal for life.
Maybe we can start with these 20,000 odd students who are interested.
So on one side we work with that college where we have in the second year about like few thousand, 2,000 students that do some things, and we get it to a point where they're about 50, 60 in the final year. It's a very slow process. But we can't go and do everything ourselves. That's on one side. On the other side, what we've done with Svecha, right? The whole summer of AI, 100,000 internships. Here we got colleges to come in and commit 1 month internship, right? And we had at least like, I don't know, maybe 40, 50,000 students that we expected from the commitment we got. Only 30,000 joined. And even there, probably like 2/3 completed lately. Now, colleges said it's one month, they're getting a certificate. We're okay. I mean, we keep talking about like every time we talk, we hear the same thing. 30,000 is not bad at all. It's just that we thought 100,000 in 2 months in the summer, it's 30,000 after 4
15
months.
lakh students every year, so you would expect 30,000 at least coming.
But it's hard, very hard. So there's access to internship, a certificate that IIT, Svecha and Meta agreed to put their name on it.
Big brand names.
We thought like it's a no-brainer, open and shut.
Yeah.
In fact, like we were discussing, we get 150,000 students, of whom 100,000 will complete.
Yeah.
We had very, and all in the summer.
Yeah.
We said to finish off by June, July. In those 2 months, this one more thing will be over. But now it's 30,000, end of the year, maybe we think we'll touch around 60,000 maybe before the main conference in February. And it's not so bad.
Okay.
So I think getting meaningful work, this is still very light work. Right? They're spending 1 month, they're learning AI and such, more they're doing the data collection. But we're giving them some training, making them build a small model. And so it's very light work. The one on the other side, the college where there's those last 20 students that come at the end of the thing, they can do good work.
Okay.
From a small college, they can do full-time development work. So, no, I mean, I'm just saying, two examples, there are no shortcuts, right? No simple solutions. If you take this YM or the other model, it's a contact, very low contact model. Very hard to get them to do anything in that model, right?
I think experience the same thing. And that spectrum exists. So, for example, one of the C4GD projects, and I think you heard that in the showcase, quantizing a Bhashini model. So, Bhashini model 450 MB, large, brought down to 150 MB with negligible drop in accuracy. I mean, that quality of a project done through this, right? And then we are struggling to even get data, like simple projects that don't require any pre-understanding of stuff. So it is a spectrum, it is hard. Hats off to you and the IIT Madras team for trying out BS in data science. It's amazing that you're running it on a project basis. So I think more of us, if we can run projects in project basis and encourage all of you to kind of partner with some academic institution, I think that helps. Some NGOs on the ground, like a Svecha that knows how to actually reach out to people and do that and bring structure to the operations. And then of course you need to have the brains like the Praveen and Ramesh's and the Mirs to go into data science. And nothing like leveraging governance. So government, when you heard the enthusiasm in the morning from a lot of government functionaries, they're like, please come, help us. And so when you work with the government, as Pragya described all of these things, right? Launched in Odisha, launched in Uttar Pradesh, 50 lakh assessments every month, imagine, happening. Why? Because it's just a directive from the government, like this is important. Chief Minister says it's important. The entire government machinery you can leverage to make that happen. So nothing like working with the government. Definitely you need to prove your point with some small pilot, and that is where the playgrounds like what Ramesh has built with smart cities and all helps. So thank you so much. All of you, I think it's been absolutely wonderful hearing all of your stories and learnings from that, being very frank about it. So really appreciate you coming today and making time for this. Thank you. Let's, we have some goodies for you, and then we have a photo.
नीचे कार्ड भेज दो अनिल के पास।
Thank you so much for that. Thanks for making it. I know you had a lot of meetings coming here. No, I won't check for the photo.
Oh, yeah.
Yeah, I can again just recreate now.
नीचे अनिल के साथ।
Come forward. Perfect. Thank you so much.